Bismillahirrahmanirrahim. Assalamualaikum and good day everyone. This is the third part of soil classification topic. In part 1, I already discussed on group of soil, then explain the characteristic for each of soil. In part 2, I have also discussed on the laboratory testing to be conducted prior classifying the soil. Now in part 3, we are going to use the data obtained from laboratory testing and classify the soil based on some standard. The original form of this system was proposed by Casagrande in 1942 for airfield construction during World War II, and the system classified soil into two broad categories. Okay, similar to previous discussion. Okay, they have a coarse grain and another one is fine grain. Okay, and if you're talking about coarse grain, it means that it dominated by what? Gravel and also sand. Okay, in which that less than 50% particle passing number 200. It means that more than 50% retain on this one, then you will consider that one is coarse. If you're talking about fine grain soil, which is it's either inorganic of clay or silt, or organic clay and silt. Okay, this means by or another one which is pit. Okay, it means that more than 50% particle passing, sieve number 200. So we are looking at the boundary of sieve number 200. So in Uscs system, they first, they divide the soil into two groups. One is coarse grain or fine grain, and how to differentiate that, okay, whether your sample is dominated by coarse or fine, they're looking at sieve number 200, either more than 50% particle passing or more than 50% particle retain. Okay, so here is retain on sieve number 200, this one is passing. Okay, or the other way around. Okay, less than 50 particle retain here, so it means that more than 50% passing, or more than 50% retain but less than 50% passing, so it will become coarse or fine grain soil. Okay, so you look at the sieve number. The things that you need to bear in your mind is you have to look at sieve number 200 and you check whether more than 50% passing or less than 50% passing. If you're talking about passing, if you're talking about retain, then it should be the other way around. So if more than 50% passing, this is fine. Is less than 50% passing, which is more than 50% retain, this would be a group for coarse grain soil. Here are the general guidance of some information needed in USCS classification system. It clearly shows that the first criteria to be considered is the material passing or retained. On what? On sieve number 200, or equivalent to 75 micrometer or 0.075 meter. Okay, so why we said you have to look at sieve number 200? Because sieve number 200 is the boundary of coarse and fine. Okay, so if let's say you have sieve, okay, remember in part 2 we already discussed on sieve analysis, and I also show you a video for further understanding. Okay, let's say this is your sieve number 200. Okay, here is your sieve number 200. Remember, when you arrange the sieve, you need to arrange from the big aperture, the big opening, okay, and followed the bottom one is the small opening. Okay, so this is number 200. So what is actually number 200 is the boundary between coarse and also fine. So here is for coarse and this one is for fine. Okay, so this is the boundary. Okay, anything that retain on sieve number 200, it means that it is belongs to coarse grain soil. Anything that passing on sieve number 200 means that it belongs to fine grain soil. So that is the first thing that you need to know. Okay, in addition to that, I hope that at this point you already know when you're talking about coarse, it means that there's another two types of soil, gravel and sand. When you're talking about fine, you have another two type of soil, which is silt and clay. Okay, if it's inorganic. If it's organic, okay, remember for fine also it can be inorganic or organic. Inorganic means that you don't have organic matter. Organic means you have organic matter. So it can be organic silt or organic clay if it has less than 75% organic matter. If more than 75% organic matter, then we call it as peat. For proper classification, according to this system, some or all following information is needed. Okay, so what you need is, you need to know what is the percentage of gravel, okay, and what is the percentage of sand, and what is the percentage of fine. Okay, a combination between silt and clay. So to know those things, okay, you have to refer to grain size distribution lab results. So it is actually from what? From sieve analysis. Okay, so gravel is whatever material that retain on sieve number 4. Sand is whatever that passing number 4 but retain on sieve number 200. And for fine, definitely anything that passing sieve number 200. So imagine this again, this is your sieve. Okay, let's say this is your number 200 is here, and maybe here is number 4. So you see that anything that retain here, okay, retain on sieve number 4, this would be a gravel. Anything that passing sieve number 4 but retain on sieve number 200, this is sand. And anything passing sieve number 200, we have fine. But can you know, is it clay or sieve? No. From sieve, you have no idea whether this fine is clay or sieve. You are not able to further identify it. So if, let's say, again I said that you from the sieve analysis testing, you find out there's a sufficient amount that passing sieve number 200, and again let's consider it's more than 10%. So you want to know whether it is clay or silt, either clay or silt, you need to carry out Alterbert limit test and get these two results. You need to carry out Alterbert limit test. So what is Alterbert limit test? Liquid limit and plastic limit. Then you will get the PI. Okay, PI is equal to LL minus PL. Additional to that, you have CU and CC. Okay, what is the function of CU and CC? It's for grading purpose. Okay, either you want to further describe your course. Okay, coarse grain soil either well graded or poorly graded. So either well graded sand or well graded gravel, or poorly graded sand or poorly graded gravel. Okay, so this all the information needed. Okay, in order for you to proceed classify your soil based on USCS system. Okay, soil symbols, plasticity and grading characteristics are listed here. Okay, this is a soil symbols, okay, plasticity characteristic, and also gradation symbols. Okay, for example, okay, before that, okay, for gravel, the symbol used is G, sand, we use L. Okay, silt, we use M. Why we don't put S? Because S is already taken by sand. Okay, all right, and clay, C, okay, organic, OPT. And if you're talking about in terms of, this is for plasticity, if you want to say that the soil has high plasticity, you are referring to liquid limit, all right, either high or low. Okay, more than 50, high, so the symbol is H. Less than 50% liquid limit, it means that it's indicate low plasticity with the symbols of L. Okay, when talking about gradations, it means that this is for grading, right? And this grading is only a second criteria to be described for course. Okay, this one is mainly for fine. Okay, so well graded, you use symbol W. Poorly graded, you use P. For example, okay, for example here, if you find out that your sample is have some sand and also silt, so how to write it? Okay, S, we know that S is for sand. What is M? M is for silk, right? M for silk, S for sand. So you look at the first letter. Anything you look at the first letter. So this is the first letter, this is the second letter. The first one means that considered as major type of soil, and this one is the minor type. So your soil consists of, most likely you have more sand, but it also have silt. So when you read it silty sand. Okay, silty sand. Okay, same thing also like this one. The first letter is sand, so we know that the type of soil is sand. But in terms of, you want to describe further about this sand, okay, it is well graded. Okay, SC, it means that what is the main? It's still sand, but it has a minor of clay. We call it clayey sand. Right? H is, we know that H is also high, but why it put is elastic? Okay, elastic is actually for high, also high plasticity. Okay, can be also put elastic. Okay. Okay, this is the procedure for classification of soil. So this is actually the example of a table or chart for USCS system. You might see a different table, different chart later from different reference book, but it is actually give you the same informations. It's just that what you need to do is you need to really understand whatever information given on each column and on each rows. Okay, so what is your first step? Step one, okay, you need to read from column, okay, from column to column, okay, from column to column. Okay, so we start with the first column. Okay, so the step one, okay, is to determine the percentage of particle retained or passing on sieve number 200, because we want to identify whether the soil sample is dominated by coarse or fine. So you have to look at these informations, and you need to check on sieve number 200, because of why? Remember, sieve number 200 is the boundary between coarse and fine. Okay, let's say from the first column you know that it is coarse, so you don't have to further look at this part, because to direct your answer later, you are moving to the next column number 2, but you are focusing on the same area. So now you're just focused on this area, so your answer will be limited to these areas only. So look at the next column. Okay, so no more looking on this part. So the next column is to identify whether it is gravel or sand, because you already know that it is coarse, so you want to know whether it is gravel or sand. So to identify whether it's gravel or sand, you have to refer to sieve number 4, because that is the boundary between gravel and also sand. Okay, again, let's say you know that it is sand. Okay, you know that from the informations of the sieve analysis, you know that it is sand. It's more dominant sand. Maybe it has also a certain amount of gravel, but which one is higher in terms of the percentage? So that is the answer. So let's say your answer is sand, so you don't have to look at this part anymore. So your answer will now, okay, when you want to move the next column, okay, you are just focused on this area. So your final answer will only limit to these 4 symbols. Okay, these 4 symbols only. Okay, so here, what is the information here on the third column? You want to know whether it has less than 5% fines or more than 12% fines. So what is the fines? Fines, it means that you have to refer back to sieve number 200. Okay, so you need to look at what is the percentage passing sieve number 200. Let's say the percentage passing number 200 is 28%. So it is more than 12%, right? So now moving to the next column, number 4, you don't have to look at this part, so you only focus here. Okay, now you only focus here. So now, okay, because it has fines 12% considered as sufficient amounts of fines to be identified whether that fines, okay, this fine is clay or silk. If you look at here, if let's say you find out your answer is this one, okay, they don't even ask you about below a line or above a line, because less than 5, we assume that it's not sufficient amounts of fine, even though it has 5% fine, but it is not sufficient to influence the behavior of that particular soil. Okay, so we want to look in terms of the grading, because we already it is sand, last we know that it is sand, but we just want to know whether in terms of its grading, whether it's well graded or poorly graded. But if let's say your answer is direct to here, we want to know, okay, you look at the last one, is either SM or SC. So what is M? It is sand with silk, okay, or SC, it is sand. The major components of that soil sample is sand, but with clay. So you have to refer to this. Okay, so what is this? This is the information that you can get from what? From plasticity chart. Okay, from plasticity chart. Okay, you get this information from plasticity chart. And what are the information needed? Is a liquid limit and also plasticity index value. So what is this? This is the parameters you need to get from Alterbert limit test. It means that you have to carry out liquid limit and plastic limit, then you calculate PI. Okay, so you have the LL here, PL here, you have A line here. Anything above A line, this will be considered as clay. Anything below A line, so this is your A line. Below A line, that will be M. So you have to refer on, so this is PI, PI, and also liquid limit informations. Okay, that's all. So you need to really understand the informations, okay, given on each column, each rows, to direct you for a correct answer. With that, thank you very much. So we end the lecture for this topic, okay, topic of soil classifications. We already discussed from part 1 until part 3, so we are finished and everything here. With that, thank you and see you later.